China is building an energy system that could turn sunlight, wind, air, and water into fuel, electricity, and industrial power. But how far can this go? With over 60% of the world's solar panels and around 65% of global electrolyser manufacturing capacity, China already controls much of the hardware behind the next energy era. Now, synthetic fuel, liquid air storage, green ammonia, and hydrogen are starting to connect into one massive system. China consumes more energy than almost any other country on Earth, and more than 70% of its oil consumption has historically depended on imports. Millions of barrels must travel across international shipping routes before reaching factories, refineries, and vehicles. That creates a serious weakness because oil can be delayed, shipping routes can be disrupted, and global prices can change overnight. So China is increasingly asking a different question. What if some of that fuel could be produced locally from air, water, and electricity? One of the most unusual developments is the attempt to produce aviation fuel using captured carbon dioxide and hydrogen. Machines remove carbon dioxide from the atmosphere, while electricity splits water into hydrogen and oxygen. The hydrogen can then be combined with carbon-based molecules to produce synthetic fuel. A 100-ton scale test facility in Shanghai began operating in 2026, moving the technology beyond a small laboratory experiment. That is tiny compared with the hundreds of millions of tons of fuel used by global aviation every year. But scaling the same process by 1,000 times would completely change the calculation. Cars can use batteries because they can carry enough energy for normal road journeys, but aircraft have a much tougher problem. Jet fuel stores huge amounts of energy in a relatively small and light package, while a massive battery would add enormous weight before an aircraft even carries passengers. That is why sustainable aviation fuel is attracting so much attention. The goal is to produce a fuel that existing aircraft can use with limited changes. If just 10% of global aviation fuel eventually came from synthetic or sustainable sources, the demand would reach tens of millions of tons every year. Renewable energy has a timing problem. Solar panels produce the most electricity during the day, while demand continues long after sunset. China is now using a different approach by cooling normal air to around -194 degrees Celsius, turning it into a liquid. When the liquid air warms up, it expands dramatically and drives turbines to produce electricity. A large liquid air storage project in Qinghai has a capacity of around 60 megawatts and 600 megawatt hours, allowing it to provide power for roughly 10 hours at full output. The material being stored is simply air, which is considerably easier to find than lithium. A 4-hour battery can help cover an evening peak, but renewable energy becomes more difficult to manage when the grid faces an entire night or several days of weak sunlight and low wind. Long-duration storage is designed for that gap. Systems capable of storing electricity for 10 hours or more can reduce the need for fossil fuel backup plants. Liquid air storage will not replace batteries completely. Batteries are better for short bursts, while technologies such as liquid air can handle longer periods. The future energy system will probably need both. Hydrogen contains a huge amount of energy by weight, but moving it around is difficult because the molecule is extremely small and light. Large quantities usually require very high pressure or extremely low temperatures, both of which require additional energy and expensive equipment. That is why hydrogen often needs a chemical carrier. One of the strongest candidates is ammonia, made using hydrogen and nitrogen from the air. Ammonia is already produced globally at a scale of more than 180 million tons per year, mainly for fertilizer, giving it an existing industrial advantage. Green ammonia uses renewable electricity to produce hydrogen, while nitrogen is separated from the atmosphere. The two elements are then combined into ammonia, converting renewable electricity into a chemical fuel that can be stored and transported. This is especially important for shipping, which moves roughly 90% of global trade by volume. A massive container ship cannot simply stop in the middle of the Pacific to recharge a battery. Ammonia offers another option because it is easier to store than liquid hydrogen. The technology is still developing, but even a small shift across the global shipping industry could create enormous demand. All of these technologies depend on one important machine called an electrolyzer. It uses electricity to split water into hydrogen and oxygen. That hydrogen can then be used for ammonia, synthetic aviation fuel, steel production, chemicals, and energy storage. China has become the world's largest manufacturing base for electrolysers, producing a major share of the equipment used globally. The difference between producing 1,000 machines and 1 million machines is not a small improvement. It is an entirely different level of industrial power. The energy transition is often described as a race to invent the next breakthrough, but manufacturing can be just as important. Solar panels, batteries, wind turbines, electrolysers, and electric vehicles become far more useful when production costs fall. China has built enormous manufacturing capacity across many of these industries. More production lowers prices, lower prices create more demand, and more demand creates even larger factories. That is how an energy transition can accelerate through scale rather than one single miracle invention. The machine may not look revolutionary, but producing 10 million of them can change the world. Companies built around traditional energy already have refineries, chemical plants, engineers, pipelines, ports, and decades of industrial experience. Many of these assets can be adapted for new fuels and chemicals. A refinery designed to process crude oil could eventually handle hydrogen-based chemicals and synthetic fuels. The transition may not simply destroy the old energy industry. Some companies may become part of the new one. The business model could gradually shift from extracting carbon from the ground to moving carbon and hydrogen through industrial systems. Renewable energy has one major weakness: sunlight and wind are not constant. Nuclear fusion could eventually provide a different kind of power by recreating the process that powers the sun. China's East Reactor has been working on the difficult problem of keeping extremely hot plasma stable for long periods, with experiments pushing beyond traditional limits in plasma density. Commercial fusion is still not ready to power homes, and major engineering problems remain. But if fusion eventually becomes practical, it could provide enormous amounts of constant electricity for hydrogen, industry, transport, and energy storage. China's real breakthrough may be the connection between renewable electricity, hydrogen, ammonia, synthetic fuels, carbon capture, and long-duration storage, turning one energy source into many. For over 100 years, global power depended on controlling oil fields, pipelines, and shipping routes. But that advantage could shift toward countries capable of building millions of energy machines. China is developing several technologies at once, from solar and hydrogen to liquid air storage and fusion, instead of relying on one solution. The bigger question is whether 10 technologies working together can slowly make oil less important. So, if energy can increasingly be produced from air, water, sunlight, wind, and machines, what becomes more valuable in the future? The fuel itself, or the technology that produces it? Because the next energy superpower may not be the country with the biggest oil field. It may be the country that builds the machines capable of turning almost anything available around us into usable energy. If you enjoyed exploring the engineering behind Huawei's latest chip, leave a like, share this video, and subscribe for more content.